Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. Today we're going to continue diving into stream-based I/O, and you're either going to love or hate this lesson. Well, that's because we're talking about binary data. Well, actually, this has nothing to do with decisions, but working with binary data anyways. So, cheesy jokes aside here, let's go ahead and dive into our favorite website here, CPP Reference, and talk about working with binary data with stream-based I/O here. So again, in the series, we've talked about things like working with writing out data with print, but again, we're in stream-based I/O here. And we've been staring at this diagram a little bit if you've been watching the previous lessons. Again, if you've missed some of those lessons, check out courses.m.io. You can enroll in this course for free. You can check out my other courses if you like here. But that's where these lessons will be, and it will be helpful if you've watched some of the previous stream-based lessons, because we're going to be looking at some of the member functions and just overall understanding how to navigate this. Now, today I'm basically going to be working with the output file streams, file stream, which is a generalization where you can do input or output, and then input file streams here. So sort of this, these bottom levels here, working with files here. And if I scroll down here, let's just go ahead and open up fstream here and look at some of the different functions here that are available. Ultimately, we want to understand how to get to the binary data so that we can understand how to read and write out binary data. So let's go ahead and keep scrolling down here. And because I'm looking at the fstream one, you're going to see a mix of, well, you'll have the istream like member functions here. You'll have your basic operations like opening files and closing files. And closing our files is actually going to be really important in this lesson here. I'm going to show you a few different bugs that can be created. So again, I want to show you some gotchas with working with files here. So I'll try to reproduce some intentionally or maybe even unintentionally, and we'll fix them. But anyways, for input file streams, right, we're reading data here. So we want to look at some of these member functions to just like read chunks of data here. That's going to be a really valuable portion of this. And of course, you can do the different things that we've talked about through this series, like, for instance, seeking and finding an exact position where you want to read a block of characters or character data from, for instance, or binary data in this instance. But we're going to treat everything like just a giant set of bytes when we're doing that read operation. Now on our output file stream here, so our output operations, we can do things like, again, use our operator here to just insert data, but we can also write a chunk of data here. And again, that's going to be pretty useful when we're writing out binary bytes, meaning that we just want to throw a bunch of data in one write call and just have it available in a file here. Okay, so those are a few of the interesting things that we're going to be talking about here. Now, if I keep scrolling down all the way, we'll find our open modes here. And there's really helpful sort of part of this here, because we're going to be talking about binary data here. So if you click on this link here for binary and text modes, it gives a little description if you want to read through this on basically what binary data is. I'll try to give you a little bit of intuition here as I leave this on the screen here. But basically, if I have some file here of some data, for instance, let's say I have 1, 2, 3, and 4. This is just some data in my C++ program here, and I can write it out basically to a file on this side into like a txt file, which basically write out the 1, an end-line character, a 2, the end-line character, a 3, an end-line character, and a 4, and the end-line character here. Okay. Or I can write it in a binary file with .bin. That's a common extension, or .data. I'll put that in parentheses, that you might see, for instance, for some like just general like raw data here. But with that, we can actually write out 1, 2, 3, 4 and just pack the data together, right? We don't need to add structure to it. I mean, we could do the same thing in a text file, but the advantage or the purpose of a binary file is, and I'll just put this here, possible or potentially smaller and less, I'm just going to say it's less public data here, right? It's in some like form here that we have the data. So somebody can't just open up the text file and start changing stuff. They have to kind of like understand the format. So it can be a little bit more secure. You can usually also compress this data. So I'll say it's more, and it's potentially more compressible, And you'll see what I mean here when we talk about writing out some of the files here. So these are some of the reasons that we want to understand sort of the binary data and writing out to binary and just not writing everything out to text. Okay, and you can read through that just a little bit here and see some of the characters here. But anyways, let's go ahead and return back to our example here. And I think we're actually ready to write some code here. So I've got a little example here. And let's just kind of start off with some of the basics here. I've included some other headers here because I do want to weave in a few different concepts here that we've been learning throughout this series, or otherwise expose you to some new things, and you can check out in this series as well if you don't understand them. But let's just start with the basics here. Let's just create a character array. Let's do 256 bytes here, and I'm going to go ahead and create an integer array here. So let's do array, and I'm going to use the array type here, again, just to throw in some things that we have previously learned here. And make sure that we don't forget these, right? With standard array here, we have the type here and the size here at compile time determined. So it's basically equivalent to this, but we have advantage that we have some member functions that we can use here, okay? So two arrays, two different types of data. So this one is 256 1-byte chars. This one's going to be 256 4-byte let's see here, not chars, ints here, okay, on most, systems, okay, because we do want to check the size of here, or even better, I'm just going to throw this out here, we do have the 32, bit width types here. Whoops, I didn't want to repeat that many. There we go here. So again, this kind of stuff does start to matter sometimes when you're playing around with data like this. So just keep that in mind here. Let me just go ahead and copy that. I'm just going to use the int type because that's what most folks are going to be using here. But I'll just say this is equivalent. This is a little better. Okay, just so we have that there in the comments. Okay. Okay, so I've got my data types here. Let's just go ahead and populate them just so they're not, in C++, the data is not guaranteed to be initialized here. So let's fill these. And I'll use int array dot size here. Again, these are both the same size, so, it's fine here. Now we could have initialized this one and then at compile time, put the size in here. That'd be okay, but again, this will work here. So anyways, our char array at I, I'm just gonna make this 99. Okay, let's just pick some value here in our int array. Maybe a little bit more interesting here. Let's just go ahead and make that equal to I here. Okay, so simple enough here. Now, what I want to go ahead and do here is let's use some streams here. I'm going to go ahead and just start with fstream here, and let's go ahead and write out our character data text. Let's just call this char array file here. I'll call it char data.txt. And how I want to use fstream, again, let's see, do I have my file modes? Here we are. This is going to write out a file here. Okay, so let's use standard iOS out here. Okay, and again, if I'm using fstream, which could be input or output, it's a good idea to have this little bit mask here and set things up here. And I could do the same thing here with let's go ahead and just use ofstream perhaps here, and I'll use my int array file here. Let's call this int data.txt. It is already, since I'm using output file stream, effectively got this out parameter here, so I'll go ahead and use that here. Okay, so there we go. Still compiling, still running here. So I'm going to say these are the character or text-based files we are writing out to. Okay, and let me actually make this a little bit more crisp here and say they're text-based, because ultimately we are just writing out characters here. Okay. Oops, let's make sure we have a return value. Surprised it didn't complain about that. There we go. And let's just go ahead and populate this data here. So again, let's go ahead and just copy this loop here effectively. We could do some, let's just go ahead and keep it simple for now. And basically what I want to do here is for my char array file, I want to write into it my char array data. Char array 256. And I'm basically going to do the same thing here with my int array file. I want to write my int array here. Okay. And I want to write that at index I. and here. Okay, so let's go ahead and compile it and run that. Great, we're looking great so far. Let's make this a little bit bigger here. And now that we're used to, we'll use the same compile commands here. So I compile it, and then I run it immediately here, and I get my files here. So let's go ahead and see what char data is. If I open that up in Vim here, actually let me split this window here. Oops, let's split it the other way here. There we go. Char data. It's a bunch of C's. Okay. So if you can recall from last time, and I'll open this up in another window here, why is it a bunch of C's here in my character array data? Let's bring in this website here, ASCII table. There's also a neat terminal tools for this, but if I find on this table here 99, so towards the top right of your screen, there is C, right? Everything's just numbers on the representation here. So that's why we get a bunch of C's printed out here, right? It's a file here with a text extension. It's, that's a clue of how to interpret this file. But ultimately, a char is just 1 byte of information here. Okay, so it's just going to say, hey, I'm the computer. I see in this text editing program here at 99, I'm going to interpret that as a character, right? 1 byte at a time here, because I'm addressing things, in that way here. Let's go ahead and do the same thing here now for our int data. And we can see basically the same thing here. We're writing out 0, 1, 2, 3, 4, 5, 6, 7. I mean, again, very clearly here, I've opened up this file, and I'm literally just writing out the integers, right? They're packed very closely together here, 0, 1, 2, 3, 4, 5, 6, whatever here. And I've got this data, all these integer data types here. Okay, so that's what we're doing here. And again, you can see over my shoulder, or just around here, 255. We move a little bit here, 254. Again, that whole collection here. Okay, so obviously, the advantage here is that we can read the text-based data here. We could even structure it in different ways here. So for instance, if I wanted to put a space between all these characters, let's go ahead and do that so we can actually interpret that. Let's go ahead and rerun this here. Let's just reopen in data, and there we can see, right? We have this structured data. We can parse it if we were reading in this format, and so on here. So it is sort of a human readable format here. Okay. Now let me get rid of these spaces here. I just wanted to show you that as a demonstration here. Okay. So what's going on here now? How do we write out the binary data here? Okay, so let's go ahead and do our binary files we are writing out to. We're going to do 2 different types of data again. I'm just going to use output file stream. Again, let's call this, I don't know, maybe char binary file. And I'm going to use an extension like bin just to indicate that it's binary. And let's do the same thing here with int binary file. And now I want to write out this data here. Okay. Now I can do the same thing here where I effectively, stream and write out some data here. But I actually want to review another function that we've used before here. Okay. So if I look at CPP reference here, let's search for the write function here. And you can see how we kind of use it here, actually, in this example here. If I want to write a chunk of data here for the size of some type here, I can do that. Let's go to the actual function here. Write inserts a block of characters. And this is unformatted output. And let's see here. Again, we looked at this previously last time. And again, what's useful about this is it's sort of like unformatted data. It says here, this function may be used to output the object representation, i.e. binary output here. Okay, so you can see we're just basically writing a collection of bytes here. Okay, and we just use it by doing write here. Now, of course, we have a file that we can call write on. Cout is just a handle to that. But anyways, that's what we're going to want to use here. So I need the type. It needs to be a const char star type here. So I might have a little bit of casting to do here. In fact, let's go ahead and I'm going to try to do this char binary file here dot write, and again the arguments, the type that we want to treat our data as, right? S is the input here, and then how many bytes that we want to write here. That's the count here. Okay. So for our characters, right, I've got 256 1-byte characters, so 256 times size of char here. Okay, and it's always good to put these size of here just to be really, really precise here. And how do I want to write out this data here? Well, this is just going to be my char array here. Let's see if that works here. Oh, just missing a semicolon. No problem there. Right, it is a char type. It is an array here, and we're basically just pointing to the first element here. Okay, so let's see here. Oops, one little mistake here. Let's just call this is a copy and paste error here. Let's just call this int data bin here. There we go. Now we should actually be able to run this. Let's look at the files we've got here, and let's open up, since we've done something with char bin, a char binary file here, char data bin, and you know, basically the same thing. It's a bunch of C's because again, these are 1 byte. We're writing out all 256 of them, and again, the computer is just going to interpret these. If I open them up, you know, in a text editor like Vim, as you know, 1 byte at a time, just you know, display you know, 256 C's here basically. Okay, but the advantage is here, and I'll go ahead and write it out here, is one write operation rather than, you know, looping here. Okay, so it's kind of nice. Or if you want control and the ability to, you know, write, you know, or maybe just write half of this data and then, you know, proceed from there, you can kind of write your own, you know, sort of buffered operations. Now, again, remember, behind the scenes, there is some buffer behind these. So again, you're, you know, but anyways, the point is you don't have to loop through every single individual value. You can just do like one write and then let the operating system handle how it's going to write out in that buffered output here. But the point is you could also chunk this. You could just take a section of it. So write is actually quite flexible and nice here. Okay, so let's do the same thing since that was working with int binary file. Well, this time we're going to be writing out integer types here, right, from this int array here. So this might cause a problem, this argument here, but let's go ahead and see what happens. So int binary file dot write. We want to write out our int array, and let's see what happens. And it's going to be 256 times size of int here. Okay, right? Integers, at least in my machine, are 4 bytes. Yours very likely. And if you want to be sure, right, you should use the fix with types here. Okay, let's go ahead and try this. I expect it'll crash. That's fine. Yeah, so it is going to crash here, right? It's telling us can't convert, you know, this array type to some char type here. Okay, how do we do that? Well, again, write is basically, you know, I basically want to convert these things into bytes, right? A file is just a stream of bytes, and that's it. Okay, and usually that means using some type of character type here. I might be able to use standard byte or something, but what I'm going to do here is reinterpret cast here and just say it's a char star here. Okay, this int array here. That means take these integers, and I don't really care, right? I'm just treating them sort of as a byte at a time here and write out that data here. Okay, so that's ultimately what I want to do here. Let's see how we did here. Invalid cast here still. Okay, why? Well, if I had just a regular, you know, C sort of style array, this would work here. But remember, int array is a little bit of abstraction here. So if I want the data here, let's not panic here. I need to do int array data. Okay, and let's do this here just to make our screen a little bit more readable here. Okay, just so you can see the full line here. This should compile, unless I mess something up. Oh, nope, there we are. We are compiling. I'll do ls. And now we should have our data written out here. I mean, let's see here. So int data binary, right? So I'm writing out the binary array here. I'm treating everything as bits. But how's this going to work out? Okay, now we get this. This has probably happened, and you can actually do this experiment where you use like Vim or something to just, you know, write out a bunch of data here. I'm getting a bunch of garbage here because remember what these values are. These are like 0, 1, 2, 3 or something. I mean, there's no representation for these in the ASCII table if you look at them. So you can go ahead and check that out. But as I go further, you'll notice sort of on a regular cadence, I'm getting 3, 4, 5, 6, 7, 8, 9, and so on. And then A, B, C, D, E, F. I mean, you can actually see the ASCII table there. Let's open that up just one more time here. Bring it in from my other window. Here it is, right? Right, you can see what the decimal values, right? That's why 0, 1, I mean, these are just like junk values. I mean, they have some meaning, right? But but meaningful text doesn't start until, well, let's find the letter, say 048 or something like that, okay? So I had to scroll down and I find my data here. Now remember, because a integer is 4 bytes of data, right, in my file example, let's go ahead and expand this just a little bit. So let's just make this clear. Int is, 1, 2, 3, 4 bytes usually. Okay, in most systems, or we could do int32t is always 4 bytes to be specific. And I'll put int in parentheses. But a char is just 1 byte here. Okay, that has a range of 0 to 255. This has a range of like negative, I don't know, 2 billion something to, 2 to positive 2 billion. I forget the exact number here, but that's the idea here. But I got 4 boxes here. And that's why what we're seeing, the data, shows up either in this box or, depending on your architecture, maybe the first box. Okay, this has to do with the endianness of your data here. So another concern here, and I'm just going to put this here, other things to think about with binary data. Okay, the endianness. Okay, so whether the significant byte is here or here when you're forming your numbers here. If you're just writing out 1 byte at a time, doesn't really matter so much, right? It's just the 1 byte here. All right, it's going to be, where do you start from? Okay, so that's just a little bit of an overview of what's going on here and why we're getting sort of, these different values here. I mean, it's sort of trying to write something out, but we can't really parse it here. Okay. Now, a few other things to take a look at here before we sort of do something with this data here. Well, actually, let's go ahead and do something with this data. Let's go ahead and read the binary data. Okay. Now let's read back the binary data to see if it was stored correctly. Okay. Basically, what I mean by read back, I want to read this int binary file here. So I'm going to use a standard input file stream here. I'm just going to call this like read binary file here. What's the file I want to read? Yeah, this one, int data.bin. And what do I want to do here? I probably just want to do a read here. So let's see if we can find read in our documentation here. That's going to be an input file stream and read. And it's going to take, some similar form here, right? Where we want to extract some block of characters, probably where we're starting from, some character array, and then, how many bytes we want to actually read here. And again, we could use different tricks like seeking to different locations here. I'm just going to use read for now. And again, yeah, we need the character type. So we're probably going to need to do cast and then how many bytes that we are reading here. Okay, so let's just leave that off to, I'll just leave it off to the side here, or I can remember it. Read binary file, read. I'm going to need to reinterpret cast. Okay, this is going to have to be a char star here. What am I casting? Well, this is, let's call it my input. Okay, 256 integers, and input data or something, or just to make this super clear, let's just call this the read data here. Okay, read data here. Right, read needs to treat these as bytes here, and again I'm going to take in 256 times size of int here. Okay. First, let's see if this compiles. Okay, did it compile? It did. Okay, so I didn't mess things up too badly. Now let's write it out here. And let's use a for loop. I'll be good. Use size t for an index value, I less than 256, I plus plus, or plus plus I don't know. And let's go ahead and say the read data here at I. And let's put a space in between just so we can kind of, parse it. And maybe an end line at the end just so we can see our command prompt. Let's go ahead and compile this. It's going to run right away here. All right, I can see my binary data here. But again, the picture to keep in your mind of what we actually did here, let's scroll up a little bit. I'll show you all the code in a moment. But again, all I did here is took this int array and I wrote numbers 0, 1, 2, 3 till 255. So I should expect if I wrote out that data into a binary file here, which I did in just one command, and I read it here in one command, I expect that I should also see 0, 1, 2, whatever. Okay, let's compile it and run it. And oh my goodness, here I've got a bunch of garbage. So what happened here? Did my file not get written properly? Actually what happened here is this is one of the cases where if we look back at our commands here, I told you before, and this is still true, again, I wasn't lying here, but this is actually the case we have to think about. OStream, iStream, and we can click on any of these here. And let me see if I can search for the keyword that I love here, RAII. Let's see if it finds it. Nope, I didn't find it. But basically what I want to say here is an OStream, right, it's still open here, and that's exactly what's going to actually be causing the problem here. If I scroll up here, right, the file that I have open for writing out data here is also open for when I'm reading it in here. Okay, so what I really need to do here is either close those files, right? And how do I close things? Well, I could put them in a different scope like this, and that would be a little bit of a safer way to do it. Or I could literally just call, here, let's undo that here, and make sure that when I'm done with operations on int binary file, I call close, okay? Let's see if that makes a difference here with our actual output here, okay? And I'll try to rerun this. And now, just like that, it works here, okay? So again, you have to close your actual files here if you're going to read for them. Because I have the same stream open, okay? So, what am I reading from? Have I finished that operation? Again, we want to make sure we close things, and for our write operations, you sort of flush out all the data there. But if I'm reading and writing from, to the same file handler from different streams, that causes problems like we saw. Maybe your operating system plays nicer than mine, but, that's what I get here. So, again, the other thing you can do, because these O streams will call their destructor automatically when they leave a scope here. That'll also work, right? That should also work here. We should get the same result and no problem there, okay? Because again, if these are allocated on the stack, the destructor, when it hits this scope, will call close on that file, no problem. Okay, so great, that works here. Okay, so again, I think we got the idea of our binary data that it looks like, basically something that's non-human readable, especially once we start writing out types that are, not characters, basically. So let's just review this a little bit here. And what I want to do here is shift our layout here just a little bit. And again, here's our files here. Now, the last thing that I'm going to talk about in this video, this has been a pretty action-packed video, is I want to list the size of these files here. Because remember from our diagram that I had here, is I said one of the advantages, again, of binary files is they're potentially smaller, okay? Is that always true? Well, it kind of depends on the data that we're writing out, right? If I'm writing a bunch of integers that are just the value like 1 or 0, 1 or 0, I'm actually wasting, potentially 3 of these boxes here. I could just represent and write that out as a 1-byte value in my file. In fact, I could actually, the proper thing to do would be to compress that into 1 byte. And stay tuned, because we will talk about that later on in the series, about different bit shifting operations so we can compress things. But ultimately, if we look at the different file sizes here, let's see what we got here. I've got my binary file 1024 bytes here. Why is that? Well, again, I wrote out in this example here 256 times 4 integers here. Okay, so that is going to be exactly 1024 bytes here. Now my character examples, right, those are all 1 byte, and I'm writing them out here. And then my text file here, where I did int data, is 658. Okay, that's a little bit more variable because, right, to represent the value 0 is 1 character. To represent the value 255, that's 3 characters. Okay, so we got a little bit larger here, so that's kind of interesting. So where does binary data start to win? Well, if we're writing out to our text-based formats, which is here, right? Again, this is our text-based section. What if I start writing out the data in a formatted way? So let's put in a space between everything, okay? So what does this do? This makes my data human readable. Okay, so let's close that out here. All right, let's see what we did. Int data, oops, dot text. Right, now I've got a space between everything. Okay, so what did that do to our file sizes? Well, if we look at our text files, they've doubled in size here. Okay, so we're getting closer to our binary file here. And our binary is basically giving us this lower bound of like whatever the data size is, or rather I should say exact bound, the data size times how many values that we've written out here. Okay, but with our text, we might be storing other things like spaces, okay, or end-line characters. Okay, let's just put in 2 spaces here to demonstrate the concept. Well, let's just put, you know, a couple. Let's just put a couple of spaces here. I mean, this is why we have the tab character thing, right? Because I don't want to write a tab that's 6 spaces. That's 6 bytes I'm paying for. When instead I could just do /t. So if you ever wonder why, you know, they chose tab. But let's just look at the file sizes here. And eventually, right, it doesn't take me very long to get these, you know, character files. I mean, this one's already much larger here, but it didn't take me that much longer here where my int data for text is much larger than bin because I'm storing all these different, you know, spaces here. Okay, this file looks like, you know, very unstructured, but, you know, ultimately look at a JSON file, look at some structured data, you're going to notice spaces and lines. If you can compress and serialize that data effectively, so you know what type of values are going to be read and exactly how many bytes, that's where you can use the binary files. Okay, so a little bit of explanation there. Hopefully this made sense. This is something I often have folks you know, write to me about how to work with binary data. I think it's a good one here. So I'm just going to say, remember to close your files before you read from them, i.e. only one open file, only one file handle to the same file should be open at a given time for reads and or writes. Okay. All right, so let's review what we did here. Again, we created a character array and an integer array, just something different, right? This could have been an array of some struct or custom data type that you had, and you do that same process of sort of writing out bytes for that actual data type, such as you could read and write it just as an individual stream of characters. We populated our data with some dummy information here. So populate with some sample data. Okay, just so we can see things. We worked with text-based files, which are basically characters here in this section here. And again, that was trivia, 1 byte at a time here. We had a little gotcha moment here where we had to close our scope, but otherwise this section is displaying how to write out binary files with different data types here, int and char. Again, the char basically being the same thing here. But again, we don't want to forget about our member functions like .write, for instance, to write out this data. And then we can pick exactly how much data we're writing out. But here, this part, we're sort of serializing our data and saying how to treat those bytes here. Okay, so that was the idea here. And then this experiment here was just showing you how to read a binary file. Okay, so hopefully that's clear here. And then here was our little review and some of the examples here. Alrighty, folks, so with that said, I'm going to go ahead and wrap up this lesson. Again, I'll point you to courses.msha.io. You can go ahead and check out this lesson or others here on the C++ series. You can track your progress and discuss with folks in the community there with fewer distractions. And that's free and available. And of course, you can check out these courses if you find those useful. But yeah, let me know what you think about it. Let me know if that answers a lot of the unsolved questions you've had about binary files. Oftentimes I've seen, and I've seen many Stack Overflow posts about this, just how to work with binary data and so on. If you'd like to see some more on this, please let me know. Please discuss below. I look forward to your comments and feedback. And as always, folks, thanks for your time and attention. I'll look forward to seeing you in the next lesson.